Welcome to Mr. V's online classroom. I'm Mr. V. I've been teaching math grades 6 through 9 for 25 years, so I hope these lessons will help you understand some concepts in math. Today we're going to be talking about the Pythagorean Theorem, Part 3. Using the Pythagorean Theorem to solve word problems. To solve word problems using the Pythagorean Theorem, you must be able to recognize the right angle in the word problem. Drawing the situation out is a big help. So let's try one together. Just follow along with me. You are trying to reach a window that is 12 feet above the ground. To be safe, you must put the base of the ladder 5 feet away from the base of the wall. How long must the ladder be to reach the window? So I'm going to draw this out. First thing I'm going to do is draw the wall that's 12 feet high and see how it's color-coded as green. So I'm going to draw and label it 12 feet. Now I'm going to draw the base. Again, color-coded, it's in light blue. And I'm going to label it as well. 5 feet. Now I'm going to draw the ladder in purple in a dashed line because it looks like a ladder to me. And again, I'm going to label it as C is equal to question mark because we don't know what C is equal to. And there it is. On the next slide, we will solve the problem. So here's the problem again. Read along with it and see how it all goes together. Again, it's color coordinated, so you know what we're talking about. Here comes the hypotenuse, or in this word problem, the ladder. So now that we have the hypotenuse label, we assign A and B to the two legs that make the right angle, and then solve for C to get the length of the ladder we need to get to that window. We assign A to the horizontal leg 5 feet, and then we assign B to the vertical leg of 12 feet. So we use the C formula of C is equal to the square root of A squared plus B squared. So C is equal to 5 squared plus 12 squared, which makes C equal to 25 plus 144, which makes C equal to the square root of 169. So that ends up being C is equal to 13 feet. Good job. Let's try another one step by step. A carpenter needs to brace a square patio frame from opposite corners Each side of the deck is 12 feet. This one again is color coordinated. How long does the brace need to be? So I'm drawing the square deck out. And there's the brace that needs to be across the way. Since I said it was square, we know it has a right angle, so we can use the Pythagorean theorem. So we say A is equal to 12 feet. That's one side of the deck. And B is equal to 12 feet. They're the same because it's a square deck. And that's one thing we know about squares, is they have 4 congruent sides. Or 4 equal sides. So there's the brace. There is one leg length. And then there's the other leg length. They are equal because it is a square. How long does that brace need to be? So again, we're going to use the C formula. And we get C is equal to the square root of A squared plus B squared. So we fill in numbers. C is equal to the square root of 12 squared plus 12 squared. That makes C equal to the square root of 144 plus 144. That makes C equal to the square root of 288. And that makes C equal to 16.97 feet. Again, I rounded it to the nearest hundredth. So good job if you could follow along with that. Let's try some more. There is a wall that is 20 feet tall. Draw and label the wall. Pause here if you need to and draw and label the wall. Next thing is, there is a moat at the bottom of the wall. Draw the moat and label. Again, this is color coordinated so you can see it easier. So here's the moat. I made it blue because of water is usually in a moat. Notice that I don't have any information about the width of the moat, so I'm going to use a question mark to represent the unknown. And then you have a 21-foot ladder. Draw and label the ladder. So I'm going to draw the ladder and get it to the edge of the moat. So now we put C is equal to 21 because we have that information. So how wide is the moat? We need to solve for B. So I'm going to write down B is equal to the square root of C squared minus A squared. So that makes B equal to the square root of 21 squared minus 20 squared. So that makes B is equal to 441 minus 400, which that makes B is equal to the square root of 41, and then B is equal to 6.40 feet. Again, round to the nearest hundredth. I'm going to let you try this one by yourself. Remember to pause so you can draw it out. A soccer field is a rectangle 100 meters wide and 130 meters long. The coach asks players to run from one corner to the other corner diagonally across the field. What is the distance to the nearest meter? Okay, so pause here and draw it out. All right, I'm drawing out the width on the bottom of the field, the length on the side of the field, the other side of the rectangle. Now, because they say it's a rectangle, we know they are right angles, so we can use the Pythagorean theorem. You have to make sure of that. And then here is how the players are going to run. So we're going to label everything now. 100 meters for the width, 130 meters for the length, and we don't know how many meters for how far they have to run. So pause here again and try and figure it out. Figure out which formula you have to use. So we get c is equal to the square root of a squared plus b squared, which makes c equal to the square root of 100 squared plus 130 squared, which equals to c is equal to the square root of 10,000 plus 16,900. And that makes c equal to the square root of 26,900. And that makes c is equal to 164.01. Because we are rounding to the nearest meter, the correct answer is going to be 164 meters. The 0.01 is rounded off. Good job. So that's our lesson on word problems in the Pythagorean Theorem. I hope you enjoyed it. Go back and watch it as often as you need. Remember, I'm Mr. V. Please like and subscribe to my channel. Help me make more math videos. Hit the bell icon so you'll get more notifications when I upload more videos. Make sure to check out these other math videos.